Okay, last week we have discussed about our microcontrollers chapter, and we just learned about microcontrollers, and microcontrollers are single board computers or single chip computers. Microcontrollers are single board or single chip computers where you can see the components related to the computer inside the microcontroller. There is one specialty. So it takes inputs and it produces outputs. No, normally a computer, it take inputs and produce output, and in the middle it process, it memorize, store and communicate. That happen. That is why in the computer you have input devices, output devices, processing devices, memory and storage, and communication devices. So inside microcontrollers also you can see all these devices: input, output, processing, memory. Memory can be volatile or non-volatile. Volatile means a temporary memory which depends on the voltage. Non-volatile means it's kind of long time memory. So we can call that non-volatile memory storage too, right? Then the processing, communication devices. These things can be seen in microcontrollers or these single chip, single board computers too. But there is a specialty. So microcontrollers can sense the environment. So actually for sensing the environment, it uses something called, yes, it uses, what it uses? Yes, it uses sensors. It uses sensors to sense the environment. So advantage of using sensors. The advantage of using sensors is, right? The advantages of using sensors is basically sensor can automatically detect the environmental changes. Sensor can automatically detect the environmental changes. Also the changes in maybe human actions. It can detect human action, environmental changes, climate changes, etc. So that is the advantage, right? It can automatically detect and communicate that or input that into the microcontroller. So microcontroller can take the action based on the feedback or based on the input given by these sensors. For an example, think about the light sensor. So when light is present, light sensor is sending a signal to the microcontroller saying that, so there's light, so light will be turned off. When light is absent in the night, the light sensor will send a message to microcontroller saying light is not there, so the bulb will lighten up. It will be automatically controlled. So if the microcontroller and sensor part is not there, then we need a human being to interrogate or work with this environment and manually see whether there is light or not, or based on a time, the particular person has to turn on the light and turn off manually. But that can cause errors. Sometimes he might forget. If he is not well, again a problem. If he is absent, again a problem. But these sensors can automatically automate the task. So what are the? Okay, so these are the things we discuss inside the microcontroller, central processing unit. Memory is there. Memory can be volatile, non-volatile. If it is a volatile memory, it is temporary. It stores data for temporary time until the power is there. If it is non-volatile, it can last for a long time. It is not erased even there is no electricity, so it will last for a long time. It is storage actually. For this non-volatile memory, you can call storage. Storage right then. So system clock that we discussed, everything is synced or synchronized according to the system clock. So think about you guys. You are schooling at same time. You are coming out of the school. You are coming out from school at the same time. How? It is synchronized. In Sri Lanka, we are working according to a single clock. It is synchronized. Everywhere the same clock is there. So vehicles, school vans, all are going according to this synchronized clock, and your school is also starting according to this synchronized clock. Your teacher is also coming according to this synchronized clock. So it all synchronized. Synchronized means it's working according to a single measurement unit. So that is system clock. Here also there is a system clock to synchronize these operations. Peripheral devices means input and output. So what are the things that you can see with these sensors and microcontrollers? Can you name a few? Yes, what you can see in your environment with microcontrollers and sensors. Can you name a few? Hello? Are you there?
Microwave oven.
Microwave oven. Okay, that is in the book anyway. Anything else? Tihan, yes? Tihan, can you repeat? Microwave oven is example, I agree. Anything else?
Sir.
Robots.
Yes. Robots.
Some
Shami?
dustbins.
Yes, Shami?
Some dustbins.
Smart dustbins. Yes. Anything else?
Sir, electronic doors.
Electronic doors. Toys. Vehicles. It can be home appliances, kitchen appliances. It can be your study room. Can be air conditioner.
Smart houses.
Yes, smart houses, smart rooms, smart classrooms. So anything that you name, even an animal or even a pet, even human beings can be connected to these microcontrollers, medical equipments, right? All these can be connected to the microcontrollers or can be microcontroller enabled and sensor enabled. So there are only 3 examples in your book, but see your environment, there are many. Right? Only 3 are listed in your book, but there are smart speakers. Yes, there are many. Okay, then we learn about the single board and single chip computers, single board, Raspberry Pi, and also you can say microbit, single chip, Arduino. Right. Use of microcontrollers. We will be learning about microbit, Arduino, and Raspberry. Right, microbit is developed by BBC Institute. Right, it has important components embedded into a single board. You can see these components. Please try to identify the components. These are programmable switches, A and B. These switches can be programmed. These are programmable switches. These are to connect inputs and outputs. This is to give the power, and this is to earth. This is to ground, and this is LED panel, which will display an output. So you can see the names below. Number 1, 2 programmable A, B buttons. Number 2, digital inputs and digital analog inputs and outputs. 1, 2, 3. Sorry, 0, 1, 2. Then LED panel is providing output. It has 25 LEDs, 5 by 5, 25 LEDs. Port to connect to the power and ground port. Power and ground. So these are the things in the front. So let's see the back. In back, there are a lot of sensors, including this is Bluetooth antenna, and this sensor is basically this is the processor, and there is a compass, accelerometer, and compass, and there is a Bluetooth antenna, reset switch. This is a micro USB to connect to the computer, and this is to give external power to the board. These are pins to connect different components. Okay, here Bluetooth smart antenna. You can see it's Bluetooth smart antenna.
Excuse me, sir.
Yes.
What is the other small processor?
Sorry.
What is the other small processor?
This one.
Yes, sir.
Should be a sensor, right? Should be a sensor. There are different sensors. So central processing unit, micro USB port, battery connected to the 3-volt supply, accelerometer and compass. These are embedded sensors. Only few embedded sensors, right? But there are a lot of sensors. And then this pin edge connector to connect to the components. Okay, how you program? You connect the computer to the microbit using micro USB cable and then transfer the port. And you can see that as a storage device there when you connect. Okay, let's go to the, you can download this from, you can code online or you can download their applications. So there's something called Make Code. So you can go to the Make Code and microbit website. There is something called Make Code and you can go there and start coding. Let's do that. makecode.microbit.org/editor. That is where you do the programming part. Here, please follow the link. By default, you will be seeing on start and forever. So this is block-based programming that we have learned in Scratch in the previous chapter. The block-based programming that we have learned in Scratch, which is the previous chapter. Okay. Have you loaded? Are you ready to code? You can see the front view and LEDs, all these things. Have you loaded this or still doing?
Yes.
Loaded.
Okay. Right, let's do the programming part now. On start means it will happen only once. When you start this by pressing the play button, this will run once. But forever will run forever. It will continue to run. In the basic, you can see there is, this is output actually show number. When you say, okay, for an example, if I say show number 0 on start, when I start, it will show number 0 in the display. That happens, right? Okay, then show LEDs. This is to control the LED panel. You can say whatever pattern. Let's give a pattern in this LED. According to the pattern that you give, it will be lighting up the LED panel as this. That can also be done. So that is show LEDs. But there are predefined patterns. Those are called icons. So there are different icons. You can see these are all predefined things. The heart, small heart, smiley, angry face. So these are emojis. So you can just display by, okay, let's say you want to display this emoji. Just add it, play it, and that will be displayed here. Right, you can see this emoji. Okay, so you can change it, right? So then show screen. That will allow you to display text. So let's display hello. That will animate the letter hello because you cannot show that at one go. Because LED has only 25 pins, so you will not be able to see that. Therefore, it will animate. Okay. Then clear screen will clear it forever, and on start, you know. Pause will wait some time. Okay, let's do something. I want to show icon, heart, and wait for 1 second. Then I want to show another icon which is smiley face. Then again, I need to wait another 1 second. So you can code like this. Plate. First it will show heart. After some time it will be erased and then smiley is there. So if you want, that can be repeated. If I put this to the forever, it will be repeated. Heart and then face, again heart, then face, again heart, then face. Likewise, it will continue. Okay, now you learn the basics. Show arrow north. This is actually showing an arrow. So let's remove the forever. You can see it showing an arrow. So this arrow can be directed into different directions. Okay. So these are the basics. Very easy. Drag and drop. That's all. I need you to do something using this. Right? Small, innovative task. Today we'll do more practicals, and next day we'll write notes and all, right? Today we'll do more practicals because still your tute is not prepared. Therefore, let's do the practical for today, and next day we can. Okay, when I press A, I need you to display letter A here. When I press B, I need you to display letter B here. So can you code it? A switch එක press කරාම A අකුර display වෙනවා. B switch එක press කරාම B අකුර display වෙනවා. When I press key A, displays A. When I press key B, it displays B. So please code that quickly. Please share it. Those who have done, can you share? Then others can reference you.
So we can't share.
Quickly, Pute. Okay, I have not enabled sharing. Now you can. Okay, simple, right? When I press key A, show screen A. When I press, when you press B, show screen B. So that is very simple, straightforward way of doing that. So that is one way. Another, any other ways of doing the same? Any other ways of doing the same? Yes. Others?
So the same way.
Same way. Okay. No comments then. So there are ways, there are multiple ways, right? You can say like this. Another way of doing the same, just go to the inputs, the second field. When I press key A and when I press key B, let's duplicate. The first one is when I press key A and the second one is when I press key B. So one thing is you can just create this customized LED panel to display A and B. That is the easiest. Another way, but it is not the easiest. You can say A. Okay, this is A and this is B. Okay, then if I start, when I press A, it will be A. When I press B, it will be B. A and B. That is one way of doing this, and you can continue this also. Then A and B. A and B. You can see this is one way of doing, or there's another way. So take a screenshot if you need. Take a screenshot if you need. Another way of doing that is just remove this part. You can say from the basic show string and show string A, and here show string B. That is another way of doing that. Okay, let's run this. Let's run this. When I press this, it's A. When I press this, B. That is another way, or you can just use forever loop. So this is another way of doing that. Take a snapshot of this. This is also correct. another way of doing that. Just going to the basics forever. And this time I'm going to use if else, or if, actually the logic. If, another if from the logicals, then I'm adding these logic variables to compare. If all right, okay, you can use this. If button A pressed, do something. If button B pressed, do another thing. This is another way of doing the same. A press, show string A, B press, show string B. So this is another way of doing the same. Let's press. When I press this, how? A. When I press this, it's B. Okay, so that is another way of doing the same. Maybe you can wait for some time, like otherwise it's not granting you the preview same time. You can just pause, pause after first. You can pause 100 seconds, 100 milliseconds, and here also you can pause 100 milliseconds just to wait. Otherwise it's not waiting, it's continuously running. So that is why small wait is needed to give the feedback. Running, pressed. Oh, for a second. Oh. So this is actually the timing problem, but still that will work. If button A is pressed, this it B is pressed, another thing that you can mention in the else part. Let's remove the pause. Press B. B comes, press A. It's not pressing properly. All right, A comes, right? Okay. Doesn't matter. You can use like this. There is another way of doing the same. Okay. That is done now. We learned 3 ways of doing the same. I need to do this now. I need to start from this corner. Right? See and understand very well. I need to start from this corner. Light up this LED, turn off that and then light up this, turn off and then light up this, turn off, then this, then this. After that, this one. So that means you should light up in this way, and then it should go this way, then this lane, this one. But each time you need to light up only one LED. All 25 need to be lightened up. All 25 LEDs need to be lightened up. Okay, now this is a challenge, another challenge. Can you do this? What you need to do, you need to light up the first LED, start from the first, go to the 20, go until the 25th LED, one by one, and you start again from the first one. So you need to rotate that from the first to 25th. 25 LEDs you need to change. So let's do this now. Okay, let's see how soon you're going to do that. Anyway, I'll help, right? I'll help, but I'll let you try first.
Sir,
Is it difficult?
quite, sir.
Done. Not yet. Is it difficult? So I don't think that. Okay, Nadun, you can share. So if you have done, so can you share? Nadun, okay. Right. Okay. So can you run and show me the code? So Nadun, can you run and show it, please? Just need to see the output. Okay. Seems he's not a. Please run the code and show. So it's not. Anyway, it's not visible. Don't know why. Maybe something wrong. Okay. Anyway, so don't you don't want to worry that much. So so that is actually he has done using coding, but you can do this with a very simple method. So let me tell so how you can do that. It's very simple. So but it will be lengthier, right? It will be lengthier. So that can happen. So okay, let's say when you need to do this forever, right? You need to do this forever. So you can drag forever from here. What do you need to do? So you need to display first thing is you need to display this slide. So then you can wait for some time. Just wait for 100. Just display the second.
Sir, but you have to duplicate it several times, sir. That's why it's really hard.
Sorry.
You have to duplicate it several times, sir.
Yeah, so that is why I said this is basic. But the thing is, it will take long time. You need to do this 25 times, right? You can see it's moving from the first one to the second one. You need to do this 25 times. But there is a way to stop that. So if you go to the coding part, still we have not learned, but if you just check the coding part, let's go to the Python coding. Then you can see this output. So let me tell how to do this using Python coding. Then you can do this. You can do it this way. If you write hash, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5. So altogether 25. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. One extra. So then if you copy and paste the same for 25 times, again it happens. So this is again, you're doing this time, you are removing this and adding it here. Okay, let's run this code now. But still, you can see that, right? Okay, so without doing that, let's do this for 1, 2, 3, 4. This. Okay, let's run this. Right, this is a shorter way. So what about this? If you mention just 2, then what will happen? Still you'll get, right? Okay, so then, yes, you can use using a for loop, but I'm just telling that, so no need to think that much of harder way. So just, you can say, this is second LED. And to get the third LED, you can just write down on the code, and that is this third LED. Let's see. This is third LED. And if you need fourth LED, you can continue to copy this. This time, fourth LED. Okay, likewise, so let's speed up the process. But this has a delay, right? This has a delay, so that's why it's on. So likewise, you can continue, right? You can continue. This is not 10 milliseconds, actually it's a plan. So this is for fifth LED. So likewise, with the dots and hashes, you can continue. Nadun, yes, you can show your loops too. So this is for the students who are doing in the basic way. Actually, if you come to the blocks, you can see the block view, right? It's actually Python code, then the 10 millisecond Python code, 10 milliseconds, so that will make it simple. So likewise, you can continue. So can you show your loop, please? So this is how you are doing using this. The second row, then it should be come to the second row. Actually, you have to draw the pattern, right? You have to draw the pattern in the second row. This is actually the first row. Yes, you can share now. Okay, you are using this as a grid and doing that. That is also totally okay. You're going from the row 0 to 5, here 0 to 5. Then you're going from index 0 to 5. Index 0 to 5 again. Row 0 to 5 means there are 5 rows. 0th row. This is how. So let me explain that. So this is the 0th row. First, second, third, fourth, and when it is 5, it will be over. Row 0 to 5. Actually, then you are going from index 0 to 5, then that this way. Okay, index 0 to 5, what you are doing, clear the screen. So you are plotting X, index and the row, and then, so plot X, you are plotting that. Plotting means you are just marking a point in the string. That point is this. Index 0, row 0, 0, 0 is this. 0, 1 is this. So likewise, you are plotting. That is another way of doing that. This is easy, but the thing is, we have not learned this repetition concept yet. We have learned this in Scratch, but we have not learned it. This microcontroller programming. But anyway, any programming concept that you learn in the Scratch can be applied in microcontroller programming too. So can you make it faster? Is it happening when you make it faster? So there is a problem in this. Actually, I couldn't see that. So is it becoming faster? So what about let's change it to 10 milliseconds. So I just want to see. Just type 10 there. I'm not sure that there's 20 something. Just try. It's moving. It's moving, but actually, so just put 1 millisecond. Just put 1 millisecond there. You should see all bulbs are on, but it's not. It's changing, right? You can see it's changing, but it should actually. So since it is fast in the practical scenario, you should see all bulbs are on. Practically, bulbs on. This is too fast. It is changing too fast. So you will see, you will observe that all bulbs are turned on. Off pain, but make a software. Since this is happening in software, you can still observe the lights are going here and there. Okay. So that is easy way of doing plotting. This is easy way of doing. Or the manual method is you can just do this manually. That is the manual method, or you can just use the block-based method and do this 25 times. So that is also okay, but it will take more time. So manually you can draw this 25 times. This is the first LED pattern. After the first LED, again the second LED pattern. Likewise, forever you can do this 25 times to get this. Likewise, then you continue. You can see this first two will go. But if you need, you can add the remaining and increase this. But that is also easy. I hope, I thought actually you will do this one at least. That is not difficult. I thought that you will at least do this one. Because this is duplicating, just duplicating and adding this to the end. That is not difficult. See, when you play that 1, 2, 3, 4, 5, it's moving. Only thing is it has a delay, right? It has a delay, unlike the previous, like the plotting example, it has a delay. Okay, so then we have discussed up to here. So we discuss what is on start, what is forever. Then we discuss about the basics. So showing number, we discuss how it happens, and showing LEDs, show icons, show screens, forever and pausing. We learn about that, clear screen and do display arrows. We learned that as well. Then, so these actions can be taken when button pressed, button A or button B, those are programmed. Or it will detect shaking also. When you shake also, you can apply certain style. When you shake also, you can see when you shake also. So that, because why it is detecting the shake? Because it has sensors. It has compass, accelerometer, gravity sensors. These sensors are there. Therefore, it's detecting that. When the pins are pressed, when buttons are pressed, right? When acceleration happens, when light level changes, when compass headings, compass direction changes, when the temperature changes, these things can be applied. Okay, next, how can you buy a microbit board? So you can see it's available in these websites like Daras. So it's costly, I know that's costly. So nowadays even Arduino board costs you 5,000, right? I think Nadun, so who bought Arduino board actually? You are lucky. So who asked me to bring Arduino board, I think he's, you know, already making illagatta Kaling Arduino board again. I think he's lucky because he got it for 2,000, 3,000 rupees. Now Arduino board price is 5,000, 6,000. That is now high. But this you can buy for comparatively low price with all the sensors. So around 7,000, around 6,000, you can buy that. If you are buying this now, but I think within next few months, it will again raise, hit 10,000 margin. So if you buy that, you can do the programming at home. But unfortunately, earlier days we were sending this, but with this cost issue, we cannot send this home nowadays because this is too expensive. Okay, then I'll stop from here. Next day I'll be continuing from that level. Then good night. See you all next week.
Good night, sir. Thank you.
Good night, sir.